where we left off. No. Okay, I'll be right back.
What?
We also know this is chapter 6, yes. You don't have a budget.
No way.
All right. Like I said, we're gonna do a handful of slides. That's it. If you did not do the notes from the first half of the section, you need to make sure that you get those done. I posted a video to YouTube, the classroom, so you have it available for you. You need to go and watch the video to get caught up on the notes, because tomorrow you're going to need them. Okay? So the first part of section 1 had us looking at a very brief history of how the periodic table was developed and a few of the early examples of how it was arranged. Okay. So now we're going to discuss the modern periodic table. So the terms that we utilize when discussing the modern periodic table are groups, periods, representative elements, transition metals. So that's what kind of terminology you'll hear me use. Groups are the columns of the elements, so the vertical portions. Okay. So all of the vertical portions, vertical columns are groups. Periods are the rows. Now think of it, if you want a little reminder of which is which, a sentence is horizontal, okay? And they are ended with a period. So the periods on the periodic table are the rows. Representative elements are groups 1, 2, and 13 through 18. Possess a wide variety of chemical and physical properties. But members in all those groups, 1, 2, and 13 through 18, members, if you're in the same column, you're going to have very similar physical and chemical properties. Then we have the transition metals, which is you may remember what block that is in terms of electron configurations. Right here. A little pop quiz from the previous chapter. What was that? I didn't hear you. What'd you say? D? Is that what you said? Yeah. If you said D, that's correct. So yeah, we'll go with it. We'll go with it, just in case you didn't. So on all of periodic tables, you have the elements. We have these elements symbols contained in these boxes, and in these boxes, you have the element's name, the symbol, the atomic number, as well as the atomic mass. Now, those are just basic bits of information that you can find. For instance, the one over there on the fume hood. Not only does it have the symbol, the atomic number, the atomic mass, but it's also got the noble gas electron configuration there. It's also got valence electrons listed there. So it's, depending on what version you get, you're going to have a kind of wide variety, but they're all going to be consistent in terms of these 4 aspects. So the table is classified into 3 different types of elements. You have the metals, nonmetals, and metalloids. Majority of the periodic table is going to consist of metals. And metals are elements that are generally shiny when smooth and clean, solid at room temperature, as well as good conductors of heat and electricity. Metals are also malleable, meaning you can be pounded into sheets, okay? Think of a mallet. A mallet can hammer into sheets. But it's also ductile or ductile, however you want to say it, which means it is drawn into wire. And the metals are broken down even further. Going away. Further divided into three categories. You have the alkali metals, alkaline earth metals, and transition elements. Alkali metals are those in group 1 with the exception of hydrogen. Hydrogen is not a metal. Starting with lithium, going all the way down to sodium, potassium, rubidium, cesium, and francium. You're in group 1 or your first column. Those are the alkali metals. The neighbors to their right, group 2, are the alkaline earth metals. Beryllium, magnesium, calcium, strontium, barium, and radium. The alkali metals, again, they are in group 1. They are very reactive. In fact, they are never found just as themselves in nature. They are always found as a compound with other elements. Because, for instance, sodium is typically found in various salts, okay, but when they break down the salts and extract sodium and isolate it, and they just have pure chunks of sodium, sodium reacts very violently with water. Even though it's a metal, you can still cut it with a knife, but you expose it to any water, and it essentially turns into a little fireball and explodes and hisses and sparks and everything like that. The alkaline earth metals are also highly reactive, but not as reactive. Once you get into like calcium and strontium and barium, that's when you start getting into the little more reactive alkaline earth metals. Then we have the transition elements that are divided into two categories. You have the transition metals that are contained within the D block. Okay, right here in the pond we kind of hopped over a few times. And then we have the inner transition metals that are contained within the F block. You have the lanthanide series and the actinide series. The lanthanide series is the first set of elements located at the bottom of the periodic table. We'll see right here. Connected to lanthanum. And then you have actinide series, a set of elements located at the bottom, connected to actinium. The other portion, known as the nonmetals, again, there's two other portions. The second largest portion, if you will, or the nonmetals, defined as elements are generally gases or brittle, dull-looking solids, poor conductors of heat and electricity. You've got halogens, noble gases that make up some nonmetals. And the halogens, excuse me, are group 17. You're also calling group 7. It just depends on which one you look at. They are highly reactive elements. The noble gases are group 18, or also known as group 8. They are extremely unreactive. That's why there are some of the last elements to be discovered, because they just simply would not react with anything we found. Some other nonmetals we have basically just don't fall in the category of halogens or noble gases. They are other nonmetals not in group 17 or 18. This includes carbon, oxygen, nitrogen, selenium, sulfur, selenium again for fun. Then you have the metalloids. These are the elements that have physical and chemical characteristics of both metals as well as nonmetals. Silicon, germanium, all considered metalloids. We also call them in terms of semimetals or semiconductors. And they form this stair-step like starting at boron, where we have boron, silicon, germanium, okay, arsenic, antimony, tellurium, astatine. So on this image, it's the green colored elements. So there you have your basics of the periodic table. And as we kind of venture further into this chapter, we're going to take a look at what other pieces of information can we decipher from how the periodic table is arranged. So that wraps up section 1. I told you to be short. But again, if you do not have the first section, you need to go back and watch this, and you have time today to do it. Yes. Yeah. Stay right there. Okay. Oops. Right, again, for those of you at home, if you do not have the first section of notes, make sure you go to Google Classroom or YouTube and look up section 6.1, part 1. Get those notes ready. Tomorrow will be a homework check, but